Okay, so this is where we left off. I believe it's lesson 3, and it's page 242. And we're just working on factoring more difficult expressions. If you take a look at this expression here, 8x4, 10x2, and a 3, it still has this general structure of the quadratic where it goes ax squared plus bx plus c. You still have that general structure where the middle term has a power value that's half of the leading term. So it's very, very similar stuff. So whatever we do for the ax squared, we can do for this 8x to the power 4. All we have to do is make it look like the one underneath. So we're going to use a substitution, and basically how to get 2 to 4, you just got to double it, or times by 2. Okay, and that's power of a power. Okay, so that's what you need for your substitutions, a power of a power, which means you multiply exponents. So we need a substitution. What's this substitution going to look like? 8x squared squared plus 10x squared minus 3. Now it has the form that we need. You could do a substitution to make it look even better. Let y equal x squared. Then you're like 8y squared plus 10y minus 3. Now it's really easy to work on because we're quite fluent on these ones. Up above it's like weird to us, x4. Okay, so that's one strategy. That's definitely one way you could go about it, and then substitute in after. I personally don't like that substitution. I find it's like kind of gives me extra couple steps I don't actually need. So you could go this way, that would be fine, or you can just break down 8 and 3 like you've always been doing, and then just use factoring by grouping. So what's the AC value? Negative 24, that's a 8 times a negative 3. And the B value is 10. So how would 24 break down? 12 and 2, that's perfect. And which one will be negative? The 2. Okay. So it's going to rewrite this guy. And I'm going to break down the middle term using 12 and 2. So you get 8x4 plus 12x squared minus 2x squared minus 3. Now I was watching you guys do your quiz, and there was only one person I saw forget to put this coefficient on. If you forget to put this coefficient x squared in the middle here, and sometimes it's x, or whatever it is, it really messes up the second step. So don't forget this coefficient. So then we put it in pairs. I'll zoom in for you guys. The GCF out of the first pair, the biggest number for 8 and 12 is, and the biggest power for 4 and 2 would be, good. Take that GCF out, you get 2x squared plus 3. And I'm pretty happy at this point because I can see the 2x squared and the 3 already in the other set of terms. So I'm like, okay, what do I need to do here? Okay, take out that negative. And I got the same thing, just the signs will switch. Now I'm at the point where I can factor out the binomial 2x squared plus 3, and the 4x squared minus 1 is left over. And then at this point, you have to have the wherewithal to understand that there is another factoring still left in one of those terms. Which one? What do you see? Difference of squares. Good. So you'll get a 2x minus 1 and a 2x plus 1 by doing difference of squares factoring on that first term. Because 4 and 1 are perfect squares, and x squared is perfect. And Laurent, you know how you use that box method? So you got to find those two numbers, and then these four terms that I found, they would go in that four-term box. Okay, a couple more on this lesson. Can I slide? Okay. Okay, so now what happens when you have some trig function in there? Is that possible? And the answer to that's yes. You see a lot of this in your trig unit in Math 30. You'll have to be able to factor these pretty fluently. What I would do here in the beginning is I would just let y equal sine x. And then you have these easy substitutions where it's 6y squared minus 7y plus a 2. And that is so much more familiar to all of us that it's quite easy to factor, and then you substitute in after. And then in the stem of the question at the top here, you can see that there's just different notations. So sine x all squared here can be written like that. It's just notation. It's just what these math people like to do. So we'll follow the notation rules. Now factoring this, AC12, B negative 7. In this situation, when the product is positive yet the sum is negative, the two terms have to both be negative. So what are they? 6 and 2. That won't work. Negative 3, negative 4. Break it down. Which one do you want to put first? Does it matter? Does not matter. Just make sure you put the coefficient on, right, Munir? Right on. Don't forget that. And now we grab GCF pairs. So a 3y. And you get 2y minus 1. And what's coming out of this one? Why do you have to factor out a negative? Say that again. The front number is negative. Good. So if you think about these pairs, this front number is positive and this front number is negative. So they have a different orientation. So you need to switch that so it matches. Right? So this is positive. This is negative. Shouldn't have that. They should both start positive and the second one should be negative. So take out a negative 2 and you get a positive 2 minus 1. Now it matches up. We're happy. We can sub in, or pardon me, we can finish this off. 3y minus 2 and 2y minus 1. Now sub that sine thing back in. So what did we say y was? Sine x. So we have 3 sine x minus 2, 2 sine x minus 1. After subbing back in. Any questions on that? Okay, so for the trig, do a substitution. Okay, so for trig, do substitution. Now, for most of this stuff in this lesson, you can do substitution, but like for class examples 2 and 3, I didn't. For class examples 2 and 3, I use this method too. And then for class example 1, we use the substitution. So in the notes, class example 1 is like method 1. Class example 2 and 3 is like method 2. And if anytime you do trig, I would use a substitution until you get good at it. Let's do a substitution, and then, like personally, I like to use x for cos, just what I'm used to. But they already have a little x in there, so I'm just going to use big X. Do you guys need me to write the let x equal sine x? No. I let big X equal cos little x. So the AC value, -12, and the B value, 11. So what happens when the AC value and the B value just differ by 1? It's the easy one, right? The one that a lot of people tend to forget about. 4 times 3? So what happens when the AC value and the B value differ by 1? Yeah, it's the trivial factor, so 12 times 1. Which one's negative? Which one's negative? -1. So you get a positive 11. You guys okay with that? Okay, so 4x squared plus 12x minus x minus 3. What should you pull out of the second one? Does you guys see it? Take out that -1. What should you pull out of the first pair? So you get x plus 3 to show up, right? You want to get that pattern. You want x plus 3 to show up. How do you go from 4 to 1, 12 to 3? Divide out. Okay, good. Take out a 4x, and you get x plus 3, like we wanted. Now take out x plus 3, and you got 4x minus 1. And then substitute back in. X is cos x, right? We just did a substitution that was a little bit easier in our lives. And you know what? You could probably try this again without the substitution. If you want, you could be like, okay, 4 cos squared plus 12 cos x minus 3, and then just factor that. But all good. Okay, now factoring when this function's a binomial. So again, same kind of structure. This is the substitution that we've been doing. Same structure. So we have the same factoring patterns. Okay, but this time we have a binomial. So no different than, if it's sine. I could put log in there. I could put any function I could think of. It does not matter. The factoring is still the same. So this is the same. If you let x minus 3 just be represented by the letter y. So let this function x minus 3 be represented by the function y. Factor it with y in there. It's way easier. Sub x minus 3 back in at the end. So I'm just going to whip through this factoring, and then I'll substitute it at the end. I'll slow down at the end. So we have minus 21. That's going to break into 7 and 3. And the 7's negative. 7y squared minus 7y plus a 3y minus 3. Take out a 7y, you get a y minus 1. Take out a 3 positive, you get a y minus 1. 7y plus 3, y minus 1. Okay, I'll slow down now. And for the substitution, just use brackets. Okay? So wherever I see a y, I need to replace with x minus 3. So I see a y there, I see a y there. I'm going to use brackets for that. So don't be afraid to double up your brackets. 7 bracket x minus 3 plus a 3 bracket x minus 3 minus 1 bracket. Okay? So wherever I saw a y, I just inserted an x minus 3. The color always helps, I think, big time. Yeah, good. So further simplification is necessary, so you multiply that in. Using distribution, you have 7x minus 21 plus 3. I'm pretty sure you guys can handle that. 2 steps in 1 step. And then x minus 3 minus 1 is x minus 4. And then if there was further factoring to do, I would. Like for example, if maybe that was a 9x instead of a 7x, then maybe you'd have 9 and 18. You could still keep going. So just always check for more factoring, always check for more simplification. And I'll jot that down here. Always check for more. Factoring or even simplifying. Questions? Concerns? Last one. What letter are we going to use? Z? Q? G? Use whatever you want. Apple. Draw an apple every time. Nine apple square. Right? Nah, we'll use 9x squared plus x minus 10. You guys okay with that? With the substitution that x equals a plus 4? So then, oh my gosh, 90. You ever hear an English person say 90? Oh, no, 90. Okay, negative 90, and then you got to get to 1. So the factors have to just be difference by 1. 10 and 9, right? 10 and 9. So which one's which? I always just jot that down. 10 and 9, and now I think negative 9. Okay, 9x squared plus a 10x minus a 9x minus a 10. Did that make sense for me to do that? I should have reordered it, right? Does it matter? It doesn't matter. It'll still work out. So the only thing I can take out is x. I get 9x plus 10. Only thing I can take out here is negative 1. I get 9x plus 10. Take out 9x plus 10 and I got x minus 1. Now I got to sub in. It's hard when you miss a class, eh, Carl? And then don't watch the video on your own time. So subbing in for x, I have 9x. So 9a plus 4 plus 10. X minus 1, so a plus 4 minus 1. Distributing and simplifying all in one step. 9a plus 36 plus 10. You okay with that? Now on the second one, I don't have to distribute anything. I just have to collect like terms. A 4 and a negative 1 give us positive 3. Do 9 and 46 have a common factor? I like how they're so confident. Yeah. 9 and 46. Yeah. Oh. Well, what divides 9? 1, obviously. 3 and 9. You just said 45 goes into 9, so it can't be 9. The only other factor left is possible is 3. Does 3 go into 46? Alright. So we're done. Okay. So with the homework, yesterday I assigned 1 and 2. So today you're going to try on page 245. Let's take a look at these homework questions. Jolene, what do you do with for E there? What do you start there with? You cry? Remember on the quiz and I told you to do something for the second or third question? Okay, I heard someone say rearrange. What else? There's one more thing. What's up with the negative on the first term? You like that? Factor out a negative. So I would, all in one step, I would factor out a negative and reorder. So all the signs switch, and I put it in the right order. Rearrange and factor out a negative. Because I know you can do these ones, but just at first glance, you're like, what the heck, right? Look at F. What do you see you should do first? How often have you ever seen the last term have an X on it? Never. So what do you need to do first? GCF, and there's an X involved. Good. Look at H. It's got pi in it. Cute. Apple pie. Change R to apple, right? Okay. So this is your challenge for today. This page here, page 245. Okay. Make sure you get all of 245 done and 246. And then I wouldn't worry too much about the multiple choice. So if you could do page 245 and 246 all, I would be so blessed. I think at this point it'd be wise for us to not move on to the next lesson. Yeah. Let some people get caught up, let some people practice. Yeah. So with that in mind, let's go 245 and 246, homework, all. And I will be walking around for 25 minutes helping you guys out. I'll go back and work on it. Okay, good luck you guys.